Okay, so dear students, you would be knowing that in your slide, there is a slide on Search 1 PPT. Okay, and this Search 1 PPT slide is, I think it's the part of week 5, and from here only your week 6 assessment starts. Okay, that is the second assessment. So in your second assessment, as you are required to optimize your solution, okay, using search techniques. Okay, so if you could see, and if you have gone through the slides, in the slides Dr. Vitali has mentioned about, there's a slide about simulated annealing, then there is a slide about random search, grid search, and all these, because these are all the type of search algorithms, okay, through which you are trying to optimize your solution. Now, to tell you the meaning of optimization is something like the cost involved while because every algorithm has its complexity. Okay, so you have to see that you are trying to build a solution in an optimized way. Okay, so that's now moving further. If you can see the next diagram, it is about the showing you the search space. Okay, so search space exactly means that, for example, you are trying to find out the possible choices that are there for a given problem. For example, when I gave you the assessment 1 and I told you to search for the best possible algorithm for your assessment. Okay, so somebody moved with something, somebody came out with different, someone, so that is searching. Okay, so searching means we are trying to find out best possible choices that are there, okay, for the particular problem. Okay, and in the next, if you could see this diagram, okay, so this diagram is just telling you about a robot navigation in a 2D plane. So now if you can recall the curse of dimensionality and a 2D example that we discussed, where there are only two axes, x-axis and y-axis. So you could see here, from here, you could see that this is the initial state. Now I can expect that you know very well the graph and all. Okay, so please see, for example, just think in your mind that this is the x-axis, this is the y-axis, and these are the points 1, 2, 3. Okay, then these are the points 1, 2, 3, and this is the first state from where the robot has started. Okay, now this is, what is this? This is transit. Transit means that it's going through that process, it's moving. So for example, whenever you book your any item from Amazon or Daraz, then you see that it says that your item is in transit at this particular station. Okay, so this is transit. So now robot is trying to search for the possible moves. So these are all the possible moves. You can see 2.1, 2.2, 2.3, 3.1, and this is somewhere, this is the reward. Reward means that this is the last stage. Okay, now the thing comes that how are we representing our search space? Okay, so normally we say that our search space are represented by a semantic network. So this diagram, can you see? This is the diagram of a semantic network. Okay, so in this diagram, you can see that it consists of nodes. So I already told you as before that these are the nodes A, D, C, E, B, and this one A, B, D, E, F, G, C. These are called as nodes in the graph or network, whatever you can say. Now, as you can see, these nodes have the concept of predecessors and successors. So predecessors means pre means something which is before. Successor is the next generation. So for example, this is, let's take an example of a family tree. This is the grandparent A, this is the child of the grand, and this is the grandchild. So D is the grandchild of A, but B is the child of A. Okay, so now how we will say? We will say that A is the predecessor of B and D is the successor of B. Okay, and when we are trying to search the last stage, for example, if we have to move to this particular point, this node, this is my search node, or I would say this is my goal state. Okay, because here my search will be succeeded. This is the last searching point. Okay, so these are the things, and what you call them, these are the arcs. Okay, ARCS. So if you could see these arcs, okay, they have an arrow, and arrow here means direction. So this clearly tells, because there are two types of graphs again. One is directed, another one is undirected. So this direction matters a lot because it tells that from which point to which point it is going. So this is all that I explained you over here. Okay, so if you could see that this is the example that they have given, that the successor of B would be D. So you could see here successor of B is D, and predecessor of B is A. Okay, so this is what they have told you to the this. And then we talk about path. Okay, so path is basically this one. This is the path. Okay, so this tells that this is a route from one node to other node. Okay, and they are connected by arcs. So normally if you try to find out the complete path, okay, so complete path would be the route from the initial stage to the final destination. So if we see our network, so here if we'll say that, we say that A, B, D and A. This one is the complete path. So A, then B, B say we have to move to D, from D we have to move to A. So this is the complete path. Then another thing that when there are two nodes in a graph, for example this, you can see two nodes, these are two nodes. Here also you could see there are two nodes. Okay, so this tells about the branch. Okay, so the branch in a network or in a tree. So the given tree here, it does not contain a cycle path. Okay, so cycle path is the one from where we start and then we again come to that particular point. That part is your cycle part. Okay, so if there is a cycled part, so then it's definite search, otherwise it's indefinite. So this is all about that.